Hello guys, substitution plus by parts plus inverse. We will consider integration of inverse functions using by parts method. Plus substitution method. Right now we have the questions in which the inverse function is not in a standard form. So we will we will change it into standard forms by substitution. We will consider the additional part as t and we will convert that in standard form, just like we are taking integration of sine inverse 3x minus 4x cube. Now this is not the standard sine inverse function, so we will consider something. We will consider x as sine theta and we substitute this value. We get sine inverse 3 sine theta minus 4 sine cube theta, but this is dx, so that's why we will differentiate this. We get dx equals to cos theta d theta. Now this becomes sine inverse and this is the formula of sine 3 theta. So sine 3 theta equals to 3 sine theta minus 4 sine cube theta. Right now we substitute this value and we will substitute the value of dx as cos theta d theta, and we know very well sine inverse of sine theta is equal to theta. So right now this becomes 3 theta and this is cos theta d theta. Right now we have theta cos theta, and in this is algebraic function and this is trigo function, so it will be the first function and this is second function on using eyelet. So we have trigonometric function and algebraic function. Now we will apply by parts method. So it is first part as it is, first function, and we will integrate the second function minus we differentiate theta and integrate cos theta, and finally whatever the result we will integrate. Right now it is theta and the integration of cos theta is sine theta minus differentiation of theta is 1 and integration of cos theta is sine theta. So right now we will integrate this sine theta. So it is 3 theta sine theta minus cos theta plus c. So as a result, now the answer in terms of thrice theta sine theta plus cos theta. Right now this answer is in terms of theta, but as our question in terms of x, so we will convert it this expression in terms of x again. So we use the substitutions or our assumptions. So x equals to sine theta and theta equals to sine inverse x, and the value of cos theta is under root of 1 minus sine square theta, and sine theta is x, so the value of cos theta is under root of 1 minus x square. So we put this theta as sine inverse x and sine theta as x, and cos theta is under root 1 minus x square. So the final answer of this question is 3x sine inverse x plus thrice under root 1 minus x square. So this is the answer. Now if we consider this question again, so what was the working method in this question? So first of all, we have a question. It is not in standard form. This is modified form or converted form. So first we will try to make it in standard inverse functions like sine inverse x. That's why we will use substitution method. So we substitute x as sine theta, and on differentiation dx equals to cos theta d theta. So we put this value, and for making this inverse as a standard function, this is the formula of sine 3 theta. According to this will be neutralized, we get theta, and this is cos theta. So these are two functions in product. Then we can use by parts, and according to by parts formula, we will integrate this and we get this result. But again, this result is in terms of theta. So answer should be in terms of x. That's why we again use substitution method, and we use our assumptions again, and we put the value theta, sine theta and cos theta like this and get the answer. So what was the working method? First we have modified inverse form in a question. So we use substitution. First step is we use substitution and make it as a standard inverse function. Now we use by parts. It is second step, and after using this by parts we integrate this and we get a result in terms of theta. So we want in terms of x again, so we used again substitution and we get the answer in terms of x. So this is the working method in this inverse part 2 or advanced inverse. So next question, that is integrate sine inverse 2x over 1 plus x square. So this is not a standard inverse function. So by substitution we will try to make it a standard function. So let x as tan theta, and differentiation of this is dx equals to sec square theta d theta. Now we put this value in this expression. We have sine inverse 2 tan theta over 1 plus tan square theta, and by trigo sine to theta in terms of tan theta is 2 tan theta over 1 plus tan square theta. So it is equivalent to sine to theta. So we will place sine inverse sine to theta, and the value of dx is sec square theta d theta, and sine inverse of sine theta according to inverse trigonometry is equivalent to theta. So right now it is theta sec square theta d theta. Right now this is algebraic function, this is trigonometric function. So by eyelet it is first function and this is second function. So this is first function, it is second function. Now we will use by parts. So it is theta and integration of sec square theta minus differentiation of theta and integration of sec square theta, and whatever the product of these two, finally we will integrate this. So it is theta and the integration of sec square theta is tan theta minus differentiation of theta is 1 and this is tan theta d theta. So it is theta tan theta and this is minus log cos theta. Integration of this is minus log of cos theta. So right now we have theta tan theta plus log cos theta. Now we replace these values in terms of x using these substitutions. So we have theta, we have x equals to tan theta, so theta is tan inverse x, and cos theta, according to this, so if we make a triangle of tan theta, so it is perpendicular over base, so it becomes 1 plus x square. So cos theta is 1 over under root 1 plus x square. So we put these values. So theta is tan inverse x and tan theta is x plus log of 1 over under root 1 plus x square plus c. So it is x tan inverse x so we place 2 also, this is 2 theta, so it is 2x tan inverse x, and we can write this minus of log 1 plus x square under root. So answer is 2x tan inverse x minus log 1 plus x square. So this is answer. There is little bit mistake, so we forget this 2 and this will be multiplied with this expression. So finally when we get 2 and half power of log comes in multiplication, that will be cancelled out. So we have the answer 2x tan inverse x minus log of 1 plus x square. So this is answer. Now next question. Integrate tan inverse of under root of 1 minus x over 1 plus x. Right now this is not a standard function, so we will substitute the value of x and try to make it a standard form. So let x is cos theta. So right now it is tan inverse under root 1 minus cos theta and 1 plus cos theta. On differentiation we get this, so we put this value in place of dx, it is minus sin theta and d theta. So it is tan inverse, and according to half angle formula 1 minus cos theta is 2 sin square theta by 2 and 1 plus cos theta is 2 cos square theta by 2. We place it in under root 2 sin square theta by 2 and 2 cos square theta by 2. Now this will be cancelled out, and this is sin square over cos square is tan square, so it comes out from under root, this is tan theta by 2, and there is minus sin theta d theta, so this will be neutralized, so you have minus half theta and sin theta, minus half theta sin theta d theta. So it is first function and this one is second function, and we will apply by parts. So according to by parts, first function as it is, we integrate second function minus differentiation of first function and integration of second, and we integrate again. Right now we have half, it is theta, and this is minus cos theta, this is 1 and this is minus cos theta. So right now we have half theta cos theta, and this is positive, and cos theta integration is sin theta, so it is minus half sin theta plus c. So right now we put the values, and cos theta is x, so theta is cos inverse x, and value of sin theta will be under root 1 minus cos square theta. So this is the value of sin theta. Right now we substitute these values. So we have half theta is cos inverse x and cos theta is x. So cos theta is x and theta is cos inverse x, minus half, the value of sin theta is under root of 1 minus x square plus c. So this is the answer, and it's very easy. Now the next question, integrate sin inverse root x dx. So again this is not sin inverse x, this is not a standard function. So right now its a requirement is this, we will substitute this, and according to situation we put x as a sin square theta. So dx will be on differentiation 2 sin theta cos theta d theta. So right now this is sin inverse and x is sin square theta, and this is dx. So this becomes sin theta, and sin inverse of sin theta is theta, and the value of dx is 2 sin theta cos theta, or you can say sin 2 theta d theta. So we can place this value, or again, so this is the first function and it is second. Right now we apply the by parts formula, it is theta integration of sin 2 theta minus differentiation of theta and integration of sin 2 theta, and this is d theta. So it is minus cos 2 theta divided by 2, and there is, it is 1 and this is minus cos 2 theta divided by 2 d theta. So it is minus half theta cos 2 theta, and this becomes positive, and the integration of cos 2 theta is sin 2 theta over 2 plus c. So this is the answer in terms of theta, but the question in terms of x, so answer should also be in terms of x. So we will substitute these values here and we collect the answer. So right now we substitute this and we have x as sin square theta. So theta will be sin inverse root x. So and cos to theta, we can write cos to theta as 1 minus 2 sin square theta, and this is 1 by 4 2 sin theta and cos theta, and this is half theta is sin inverse root x, and it is 1 minus 2 x. So sin square theta is x, so we substitute this plus 1 by 4, or you can say 1 by 2, and there is sin theta. Sin theta is under root x, and cos theta will be under root of 1 minus sin square theta, and sin square theta is x, so it is 1 minus x. So we substitute this value under root 1 minus x plus c. So it is, when you multiply this negative sign, you get half 2x minus 1 sin inverse root x plus half under root x into 1 minus x plus c. So this is the answer, and this is an important question.